Sam Altman asked recently how many robots would you want? He said he'd want at least 1,000. Let's stay with that. Because what would you actually want 1,000 of something for? Maybe you'd want 1,000 tutors who each specialize in a different sliver of knowledge, or 1,000 architects drafting 1,000 versions of the home you've always half imagined. The wish itself would become the interesting part. The bottleneck wouldn't be computation anymore, but imagination. Psychologists call this a kind of Maslow's escalation. Once the lower needs are met, the desires don't vanish. They climb. They get stranger and more personal. They become the fingerprint of who you actually are. Sam says we're not close to 1,000, not in the physical world, not yet. But I think what we might actually be watching is a countdown. Not to 1,000 robots in your living room, but to a single moment. The moment a robot can build another robot. That's it. That's the event. And you might be thinking, we already have factories full of machines making machines. But let me introduce you to a figure I'll call the assembler. The assembler isn't just a welding arm bolted to a factory floor. The assembler is a system that can source its own materials, diagnose its own failures, improve its own design, and produce a copy of itself. A complete, autonomous reproductive cycle. We are going to need the assembler later, and we're going to need to talk about why the assembler sweats, metaphorically speaking. But first, we have to acknowledge the gap between building a thing and building a thing that builds itself. We also have to acknowledge that the word autonomy might just be a prettier way of saying a feedback loop we stopped monitoring. The first time a robot builds another robot from end to end, it might take a year, maybe longer. 12 months of sourcing, fabricating, calibrating, testing. But here's the thing about compression. The second cycle might take 6 months, the third 3, and then it starts to look less like manufacturing and more like something biological, Moore's law on legs. Let me walk through what that might look like. If the first robot takes 12 months to build its successor, and each generation halves the build time, then by the 7th or 8th generation, a single robot could be producing copies of itself in a matter of days. Within roughly 5 to 7 years of that first successful self-build, a person could, in theory, have access to 1,000 robots. Not because someone manufactured 1,000 units and shipped them in boxes, but because the first one kept making the next one, and the process itself got smarter. Now, 1,000 robots in your physical life, what does that actually look like? Start with the mundane. One does the dishes, one maintains the yard, a few handle logistics, groceries, repairs, the invisible infrastructure of a human day. That alone would change what a life feels like. There's a concept in behavioral economics called the attention tax, the cumulative cognitive cost of managing all the small obligations that don't individually seem significant, but collectively eat your bandwidth. 1,000 robots might be the thing that finally pays that tax in full. But the vision gets stranger and more interesting when you push past chores. Because here's something that might not be obvious at first. You, the essence of who you are, your particular way of seeing the world, your humor, your priorities, your instincts about people, that essence can only interact with so many humans in a lifetime. And only so deeply. There are physical limits. You can maintain roughly 150 meaningful relationships, that's Dunbar's number, an anthropological ceiling that hasn't budged since we were living in small groups on savannas. You can have maybe 5 to 15 truly deep relationships, and those take decades to build. But what if your robots weren't just servants? What if they were emissaries, extensions of your intent, your values, your curiosity, moving through the world on your behalf? Like 1,000 octopus tentacles, each one feeling a different surface, reaching into a different room, touching a different life. One attends a community meeting you care about but can't get to. Another has a conversation with a stranger at a conference and reports back what it learned. Another spends 3 months learning a skill you've always wanted but never had time for. Consider a parallel. In medieval Europe, monarchs couldn't be everywhere at once, so they sent ambassadors. These ambassadors didn't just deliver messages, they embodied the sovereign's judgment. They made decisions in real time, adapted to local conditions, and projected power through presence. Your fleet of robotic emissaries might function the same way, not as simple tools, but as deputies of your will operating in spaces you can't physically occupy. This is the network extension hypothesis playing out in hardware. Your social and intellectual reach isn't limited by your body anymore. It's limited by how many extensions of yourself you can meaningfully direct. But 1,000 won't be enough. I know that already, and you probably do too. Because once you experience what 1,000 can do, the desire will scale. That's the hedonic treadmill, the well-documented tendency for satisfaction to reset to baseline after any gain. 1,000 will feel revolutionary for a month, and then simply normal. So let me ask, what about 1,000,000? Here's the honest problem. There isn't room. Not in the physical world, not for everyone. If 8 billion people each wanted 1,000,000 physical robots, we'd need 8 quadrillion machines navigating the same roads, the same sidewalks, the same grocery stores. The planet isn't built for that. The bottleneck isn't intelligence or even manufacturing. It's space, square footage, atoms. Let me come back to the assembler for a moment. Remember the gap we identified, the one between building a thing and building a thing that builds itself? The assembler solves the production problem, but the assembler can't solve the volume problem. You can make copies of yourself endlessly in a room, but at some point the room is full. That's not a failure of engineering, that's geometry. And this is where the story shifts, because there's another world with no geometry problem at all. Cyberspace has no square footage, no atoms, no upper limit on how many agents can operate simultaneously. If the physical world is where 1,000 robots feels like the ceiling, the digital world is where 1,000,000 becomes the floor. And what might 1,000,000 AI agents do in simulated space? They could build economies, test civilizations, run pharmaceutical trials in virtual biologies, compose music, write literature, negotiate treaties between fictional nations just to see which governance models survive. They could explore mathematics we haven't invented notation for. They could simulate your business idea 100,000 times before you invest a single dollar. And here's the thought that keeps pulling at me. What if that becomes the primary way human beings create value? Not through our physical labor, not through our presence in a room, but through the worlds our millions of artificial intelligences build and maintain in digital space. There is a concept in economics called comparative advantage, the idea that even if one party is better at everything, trade still benefits both because each can specialize in what they do relatively best. Right now, humanity's comparative advantage is creativity, judgment, desire, the ability to want things and decide which things are worth wanting. But the arena where that advantage plays out might shift entirely. The value we bring might not be measured in widgets produced or services rendered, but in the richness, complexity, and originality of the simulated worlds we architect. You become a curator of realities, a gardener of digital ecosystems. The thing that makes you irreplaceable isn't your ability to code or build or carry, it's your taste, your particular irreducible vision of what a world should feel like. Now let me return to the assembler. Remember the sweat? Here's why the assembler sweats. Because the assembler is caught between two truths. In the physical world, every copy it makes brings the ceiling closer. The room fills. The resource is thin. Every new unit is a small victory and a small erosion of what's left. The assembler sweats because it was designed for the physical world, but its destiny might be digital. It's straddling a border between scarcity and infinity and doesn't know which direction to face. Sam Altman imagined 1,000 co-workers. I think that's a starting point, not a destination. 1,000 might be what you get in the real world, where space is finite and atoms are stubborn. But in the spaces we haven't built yet, the number is whatever you can imagine and whatever you can direct with taste, judgment, and vision. And if that sounds like it could be beautiful or terrifying or both, then perhaps it's worth sitting with that feeling for a moment. Because the distance between 1,000 physical arms and 1,000,000 digital ones is not a technological gap, it's a philosophical one. It's the difference between asking, how many can I build, and asking, how many worlds can I dream?